Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. China's Thousand Sails joins the satellite mega-constellation boom. China's Thousand Sails joins Starlink as the latest mega-satellite constellation in orbit, marking a significant step in the rapidly growing field of low Earth orbit (LEO) satellite constellations. With the ever-increasing number of satellites crowding LEO, it has become a familiar sight to see strings of satellites streaking across the night sky, particularly from SpaceX's Starlink constellation. These mega-constellations, designed to provide global internet coverage and communication capabilities, are transforming the way we connect, but they also present challenges, particularly for astronomers and skywatchers. In recent years, the advent of these satellite trains, most notably from Starlink, has not only sparked discussions about the impact on ground-based astronomy but has also contributed to the rise of UFO reports, as the unusual sight of rows of satellites prompts curiosity and confusion. With more agencies and companies launching their own constellations, the skies are becoming increasingly filled with artificial satellites. This trend is expected to accelerate in 2024 and beyond, with more satellite launches planned. One of the significant concerns raised by the astronomical community is the interference these satellites create for deep sky observations. The bright streaks they leave in images can ruin long exposure shots of distant celestial objects, and this issue is particularly concerning for upcoming large-scale sky surveys such as the Vera Rubin Observatory, which is scheduled to see its first light in 2025. This observatory will conduct extensive sky surveys that could be compromised by the presence of numerous satellites in LEO. SpaceX has taken steps to address these concerns by implementing several mitigation measures for its Starlink satellites. These measures include adding sun visors to the first generation of satellites, using diffuse dielectric mirrors on the newer V2 platforms, and adjusting the angle of the solar arrays to reduce their brightness. These modifications have shown some success in reducing the visibility of the satellites from the ground, with spotters noting that the newer V2 satellites have a fainter, bluish tint and are less visible once they reach their designated orbits, with an average magnitude of around +7, which aligns with the threshold set by the National Science Foundation, NSF, and the International Astronomical Union, IAU. However, the proliferation of satellite constellations has also introduced challenges in the radio frequency spectrum. Radio noise generated by these satellites can interfere with astronomical observations, especially in the radio wavelengths. The Low Frequency Array, LOFAR, in the Netherlands, one of the world's leading radio observatories, has detected significant radio emissions from the V2 mini Starlink satellites, noting that they emit 32 times more unintended radio waves than their predecessors. This unintended radio interference is a growing concern for astronomers who rely on sensitive radio telescopes to study the universe. China's entrance into the field of mega-satellite constellations is marked by its Thousand Sails initiative, a project spearheaded by Shanghai Spacecom Satellite Technology, SSST. This ambitious effort aims to launch 1,296 satellites into orbit by 2027, with plans to expand the network to a staggering 12,000 satellites by the 2030s. The first batch of 18 satellites was launched aboard a Long March 6 rocket from the Taiyuan Satellite Launch Center, entering a polar sun-synchronous orbit. This marks China's answer to SpaceX's Starlink, and satellite spotters quickly detected the train of satellites shortly after the launch. In addition to the Thousand Sails initiative, China has also been working on other satellite constellations for various applications. For instance, on September 5, 2024, a Long March 6 rocket launched 10 satellites for the Geely Group, aimed at creating a communication network for autonomous vehicles. Another batch of 18 satellites for the Thousand Sails initiative was launched in mid-October, further adding to the growing number of satellites in LEO. These satellites have been observed with an estimated brightness of up to +4 magnitude when visible near the zenith. Unlike SpaceX, which has made efforts to mitigate the impact of its satellites on astronomy, China is not bound by any international agreements or obligations to reduce the visibility of its satellite constellations. As a result, the continued expansion of satellite networks in LEO is likely to have an increasingly profound impact on the night sky, raising concerns about the future of astronomical observations and our ability to study the cosmos from Earth. The competition to launch mega-satellite constellations extends beyond China and SpaceX. Other companies are also racing to establish their presence in LEO. SpaceX has diversified its satellite deployments, launching not only Starlink satellites but also platforms for other companies. For example, in September 2024, SpaceX launched 5 Bluebird satellites for AST Mobile, a follow-up to the Blue Walker 3 test satellite. Blue Walker 3, known for its massive 10-meter wide phased array antenna, has been observed to shine as brightly as magnitude 0, making it one of the brightest objects in the night sky. AST Mobile plans to deploy 110 Bluebird satellites in the coming years, each potentially contributing to the growing brightness of the artificial sky. OneWeb, another competitor in the satellite communication market, has faced setbacks due to geopolitical tensions, particularly the ongoing Russia-Ukraine conflict. As a result, OneWeb has had to shift its launch strategy, relying on SpaceX to get its satellites into orbit. Despite these challenges, OneWeb's satellite constellation now includes 660 satellites, close to its initial target for providing global internet coverage. The company has already begun offering services through providers like HughesNet and Viasat, further increasing the number of satellites in operation. SpaceX's Starlink remains the largest constellation in orbit, with over 7,000 satellites currently in operation. The company continues to launch new satellites at a rapid pace, with plans to deploy 12,000 satellites in the near future and potentially expand to a total of 34,400 satellites in the coming years. This exponential growth in satellite numbers has led to concerns about the long-term sustainability of LEO and the potential for increased satellite collisions and debris generation, known as the Kessler syndrome. In addition to commercial ventures, governments are also getting involved in the deployment of satellite constellations. The U.S. Department of Defense, DoD, has launched its own satellite constellation, known as Starshield, which currently includes 73 satellites in orbit, with plans to expand to over 100 satellites. As expected, the DoD has become one of the largest customers of SpaceX, leveraging the Starlink infrastructure for military applications. The rapid expansion of satellite constellations has also fueled interest in tracking and observing these objects from the ground. Amateur astronomers and satellite trackers have become increasingly engaged in documenting the movements of these constellations, particularly as they grow in size and brightness. For example, ACS-3, the Advanced Composite Solar Sail System, a solar sail satellite launched by Rocket Lab in April 2024, has become a popular target for observers. The satellite's solar sail reflects sunlight, making it visible as a bright object in the night sky, and it has been observed to flare up to magnitude 0 on certain passes. Looking ahead, the continued growth of mega-satellite constellations presents both opportunities and challenges. On the one hand, these networks promise to provide global internet coverage, connect remote regions, and support various communication and scientific endeavors. On the other hand, they pose significant risks to ground-based astronomy, radio observations, and the overall aesthetic of the night sky. As the number of satellites in LEO continues to rise, it will be essential for the global community to establish regulations and standards to ensure the responsible use of space and the preservation of the night sky as a shared resource. In conclusion, China's Thousand Sails initiative represents a significant milestone in the development of LEO satellite constellations, joining the ranks of Starlink and other ambitious projects. As the skies above Earth become increasingly populated with artificial satellites, the need for careful management and mitigation of their impacts on astronomy and space exploration becomes more pressing. Whether we are entering an era of unprecedented connectivity or sacrificing the beauty and clarity of the night sky remains to be seen. But one thing is certain: the race to fill LEO with satellites is far from over.